Right, let's take a look at number 6. We have to take the second derivative because it's a double prime of f of x, which is equal to e to the 3x cosine x. Now I'm looking at this one. There's two functions being multiplied, e function and cosine function. So I'm going to be applying the product rule. So let's recall the formula for the product rule. So the product rule states that if you have g of x, h of x, the derivative will be g prime of x, hx, plus g of x, h prime x. So let's begin finding first derivative. So g prime of x, so derivative of e to the 3x, that's a chain rule. So e to the 3x, derivative of 3x is 3. So I have 3e to the 3x. And then h of x, just cosine x. Plus derivative of, so it's just original g of x, so e to the 3x. Derivative of a cosine will be negative sine x. So we get the first derivative, 3e to the 3x cosine x minus, because you have a plus and minus, e to the 3x sine x. So that's my first derivative. Now let's take the second derivative. So I'm looking at this. I have to take product rule twice because this first term is a product rule and second one is also product rule. Two things being multiplied. So we have to do product rule twice. Now here's a shortcut. If you really look at it carefully, this first term looks very similar to our original function, except there's 3 in front. So I'm not going to redo the problem. I'm just going to copy exactly what the derivative of this is, this one here, which is this part, and multiply by 3. Is everybody seeing that? Right? So derivative of e to the 3x cosine x is this whole thing here. Copy, and then I'm just gonna multiply that by 3 so that I'm saving time. Okay. All right. Now subtract. I have to take the derivative for this part. That requires a product rule. So let's do it. So I'm going to have 3e to the 3x, that's the derivative, sine x, plus g of x is e to the 3x, derivative of a sine is cosine x. Okay. Now let's do some math, distribute and simplify. Here, if I distribute 3, I'm going to get 9e to the 3x cosine x minus 3e to the 3x sine x. Distribute the negative, minus 3e to the 3x sine x minus e to the 3x cosine x. Now there are like terms, so I'm going to combine them. So this one we have e term and then cosine x that I can combine. And I also have this one over here, the sine terms. So how many do we have? 9 take away negative 1, which is 8e to the 3x cosine x. Here I'm going to have negative 6 e to the 3x sine x. So that will be my final answer. Okay. Let's take a look at the last problem of the section, and this is homework problem number 9. Okay, so it's exact same problem. So let's try this. Find the slope of a tangent to the graph of f of x equal to sine 4x at x equal pi over 24. So first, the word slope to the tangent line means take the derivative. That's what the slope means. But where? And then evaluate it at pi over 24. So that's what the question is asking. So let's first take the derivative. This one is a chain rule. So sine u du times 4. So, I'm sorry. So derivative of sine is not sine, cosine. So cosine of 4x times derivative of u, which is 4. So I'm going to have f prime of x is equal to 4 cosine 4x. Now I need to evaluate at pi over 24. So 4 cosine 4 times pi over 24. Well, this part here can be reduced. 4 goes into 24 6 times, so cosine of pi over 6. Now, this is why we review in 8.1 and 8.2. Cosine of pi over 6, that's the known triangle. So cosine value at pi over 6 is 4 times root 3 over 2. 2 cancel with 4 twice. So final answer, the slope at x equal pi over 4 is 2 root 3. Okay. All right. That is 8.3. So derivative of trig function. Now we are gonna move on to taking the integral of the trigonometric function. In this particular section, we are going to be focusing on just the two functions, sines and cosine. So integration is the opposite of derivative, right? So if the derivative of a sine was cosine, then antiderivative of sine is cosine with the negative. Antiderivative of a cosine will be positive sine. So it's the exact opposite of derivative. So same thing, u substitution also holds here, so you can apply u substitution as well. So let's begin with number 1. You can see that it's not just simply cosine x dx. We have a cosine of something extra dx. So let's apply u substitution. Let u be 12x. Then my dx du will be 12 dx. So we can solve for dx. So 1 over 12 du equal dx, and we are going to substitute it. So I have cosine of u. My dx is now 1 over 12 du. I can take the constant out of the integral. So 1 over 12 cosine u du. Now cosine u is a sine u plus c. So 1 over 12 sine u plus c. Don't forget plus c because this is a definite integral. I'm sorry, indefinite integral. There's no number to plug it in. Finally, we did the u substitution, so substitute u back. So 1 over 12 sine 12x plus c. Now, do not ever cancel this 12 and this 12 because 12 in here is inside of a function. So you cannot cancel this out. Okay, so just leave it as like this. Okay, so very simple. So we are going to be practicing a couple more so that you feel comfortable with the antiderivative. So we'll look at a couple different scenarios. Number 2, we have cosine x to the 5th power sine x dx. Now here, same thing. I'm going to be selecting u nicely so that it cancels out. So let's think about this. I have something to the power, so my first attempt will be set cosine as set u as a cosine x because you have a cosine inside of a bigger function. Then my du will be, well, derivative of cosine from last section. That's a negative sine x dx. That's nice because you have this sine x dx. In other words, you can divide it by -1, so negative du is sine x dx. So I'm going to replace the sine dx as negative du, and then u will be my cosine x. Okay. So I have u to the 5th power. This part over here is negative 1 du. Take out the negative in front. So negative u to the 5th power du. This is a very simple one. Power rule, raise power divided by new power. So I'm going to have negative u to the 6th power over 6 plus c. Substituting back, don't forget to plus c because I'm not evaluating. So negative cosine x to the 6th power over 6 plus c will be my final answer. Okay. All right. Number 3. Again, this looks more complicated, so I'm going to be using some u. You have options. So I'm looking at this one. I have, this looks more messy. So I'm gonna set my u as 6x squared plus 7x minus 12. Then my du is 12x plus 7 dx. And that's nice because I have that over here. So I have, so my du will be this whole thing. So it cancels out nicely. So sine u du, antiderivative of sine u is a negative cosine u plus c. So this will be equal to negative cosine u plus c. So I'm going to have negative cosine 6x squared plus 7x minus 12 plus c. Done. Okay. All right. Next one, number 4. So I have a fraction sine 5x, cosine 5x. Now, couple of options to let you. If I do 5x, now take a moment. Sometimes you have to try a couple times to get the right u. If I have 5x, I have du as 5 dx, and that doesn't really help me because I still have, then in this case, we have a sine u and then cosine u. And then I don't know how to take the derivative of this. I only know separate one, sine and cosine, but not as a fraction. So my u will not work nicely when I said 5x. So what are some options? Well, if I do one function as a u, I'm going to kind of get the other one by the derivative, right? So you try a couple things. The u that works will be cosine 5x, the whole thing on the bottom. Then my du, derivative of cosine is a negative sine, and then dx will be 5. So I have du is negative 5 sine 5x dx. And that's kind of, and then we are gonna see that sine 5x dx is kind of like hidden here. So we solve for dx, and then if I solve for dx, I'm going to divide it by negative 5 sine 5x. Let's put it on the side here. Negative 5 sine 5x. So my dx is 1 over negative 5 sine 5x. So I'm going to substitute that. For my dx, it will be replaced to this whole thing here. Okay, then I have sine 5x. This part is my u. My dx is 1 over 1 over negative 5 sine 5x by du. That will be my dx, right? So cancel the sine 5x, sine 5x. I have negative 1 over u times 1 over negative 5 du. This is a constant that I can pull out. So negative 1 over 5, 1 over u du. And antiderivative of 1 over du, that was the tricky one. That's the ln u. So I have negative 1 over 5 ln absolute value of u. Don't forget to put plus c. Substituting back, I have negative 1 over 5 ln. My u is cosine 5x, so cosine 5x plus c. Okay. All right. Now let's do some definite integral where they give you the boundaries. So I have two problems, number 6 and number 7. Let's start with number 6. Number 6, I have a sine of x dx integrating from 0 to pi. Okay. So over here, so I have so this one is a very simple one, no u substitution. So antiderivative of a sine is a negative cosine u. So I have a negative cosine x integrating from 0 to pi. So I have a negative cosine pi minus negative cosine of 0. Okay. So cosine of pi is negative 1. And then minus cosine of 0 is positive 1. But here you have a negative, so negative 1. So I have negative 1 plus 1, so I get 0 as the final answer. Okay. One more, evaluating. So we have cosine of x. So antiderivative of a cosine is a sine. So sine x integrating from pi over 4 to 3 pi over 4. So sine of 3 pi over 2, subtract sine of pi over 4. All these we have practiced, and these are the known angle from calculus, from trig function that we reviewed last time. So I have sine of 3 pi over 1, that is a quadrant angle negative 1. Sine of pi over 4, that's a 45, 45. So that's a root 2 over 2. Okay. So finding the common denominator, negative 2 over 2 minus root 2 over 2. So negative 2 minus root 2 over 2 will be final answer. Okay. All right, one more problem, and this is your homework problem. Okay, so this is a little bit of an application problem, so let's go over this. This is your last homework problem. Okay, so here, suppose that the profit on the sale of a swimming suit in a department store are given approximately by the following function P of T, where P of T is the profit in $100 for a week of sale, T weeks after January 1st, from 0 to 104. So T represents the number of weeks. And our function is 5 minus 5 cosine pi T over 26. Use the definite integral to approximate a total profit during the 2-year period. So part A, I need to set up from total of 2-year period. So that's 0 all the way up to 2-year. Now, be careful, my T is in weeks, so we have to count the number of weeks in 2 years. Well, 1-year period, there are 52 weeks. So double that, 2-year. How many weeks are there? 104 weeks. So basically, we are getting from 0 to 104. Okay, so unit, be careful with the different unit. You need to convert it into 1 unit. And then integrating from 5 to 5 cosine pi t over 26 dt. Okay, so let's integrate this. Over here, I'm going to have, I can pull out the 5. I can factor that out. So let's do that. 5. So 1 minus cosine pi t over 26 dt. And then 5 is a constant, so I can pull that out. So I have a 5 integrating from 0 to 104. 1 minus cosine pi t over 26 dt. Because it's a subtraction, I can separate integral to 2 different things. So 5 still there. First one 0 to 104 1 dt. The second integral 0 to 104 cosine pi t over 26 dt. This one is a very easy one to integrate, so let's do that. So this part here, derivative, antiderivative of 1 is a t. So we have a t going from 0 to 104. Now over here, this integral, this requires a u substitution, right? So let's set up a u substitution. So my u will be pi t over 26. In other words, let me rewrite that. U is pi over 26t. So pi over 26 is a constant, so my derivative is just pi over 26 dt. So let's solve for dt. Divide by pi over 26. Pi over 26 dt is equal to 26 over pi du. So that's what I'm going to be substituting for my dt. Okay, so let's keep going. So if I substitute it, I'll leave it as a question mark for now because it's a du. So I have cosine of u, that's my u, dt will be 26 pi over du. Keep going, 5, integrating from t 0 to 104. You can integrate it, but I'll just leave it for now. I want to finish integrating the second term. So 26 pi can be pulled out. So I have 26 over pi going from some question mark because it's still u, cosine u du. Keep going, integrating 0 to 104, negative 26 pi. Cosine of u, antiderivative of cosine u is positive sine u. So that will be positive sine u. Okay. I'm going to copy this and continue on the next page. So I have 5 going from 0 to 104, and then I have 26 over pi. Now let's substitute our u. U was pi t over 26. So pi over 26t. And then it was integrating from 0 to 104. Now we are finally ready to plug it in. So first one, this part over here, so that will be 104 minus 0 minus this part over here, that's 26 over pi sine pi over 26 times 104 minus 26 over pi sine pi over 26 times 0. Let's keep going. So I have a 5 times 104 minus Now 26 can be reduced with 104 4 times. So I have minus 26 over pi sine of 4 pi minus 26 over pi sine of 0. Okay, distributing all the negative, 5 times 104 minus 26 pi sine 4 pi, and then plus 26 pi sine of 0. Okay. Now I have 104 sine of 4 pi. Those are the quadrant angle. That's a known angle. So that's actually 0. So this part ended up being just a 0. Sine of 0 is also 0. So this one is also 0. So you end up having just 104 inside of that bracket. Okay. So 5 times 104, I get 520. Done. So first one, you have approximately perfect number of $520, $100. Part B is exactly the same, so I'll let you do it as a practice, but we are integrating same thing, except instead of 0 to 104, you're integrating from 13 to 26 of our function. 5 minus 5 cosine pi over 26t dt. So I'll let you practice that as an additional problem. Part C, finally, is asking you to graphically choose the appropriate shaded region of total profit from 13 to 26. All right, so I'll use a graphing calculator to do that. Now I'm looking at all my 4 options, and then all my graph t value, in other words, x-axis, starts with 0 all the way up to 104. So t is between my x's. T is between 0 to 104. So on the calculator, that will be my x value, x-axis. And then y is all going from, p of t actually is going from 0 to t. So that's my y-axis, 0 to t. I'm going to set these numbers so that I have the same setup with my options. So let's pull that out. I have and then double checking, my mode is radians, good. So I have 5 minus 5 cosine pi x divided by 26. So window, remember my t was 0 to 104. And then I don't want to count by ones because it's too many, right? So I'll just count it by 10. X mean was a 0 all the way up to 10. So this is the graph that I'm having. So let's copy this. And then since this one, and then let's pull that out. So let's take a look at which one is the bestly matching. So I'm looking at this one here. And then my best one, I know I can eliminate this one. It's either this or this. But we are looking at only from 13 to 16. So if we zoom in a little bit, 13 is, if this is 20, 13 is somewhere, this is 10, so 13 is here, all the way up to 26, somewhere here. So I should have this portion shaded. So my best answer will be the second choice. Okay, that's it for chapter 8. On next video, we are going to talk about chapter 9.